Lesson 4-2 will be talking about greatest common factors, or the GCF. And as we work more with fractions, we're going to be using the greatest common factor a lot to simplify fractions, or eventually work to find least common multiples and things like that. So finding the greatest common factor is a key skill for this chapter. And to do this, I'm going to introduce the L method for us to use. It's a useful tool that we can use to identify many different things. We can actually use it to simplify fractions, find the greatest common factor, find the least common multiple. It's a really useful method of working with two numbers or more numbers. So the L method is not shown in your book, and it's not on any of the online tutors. So this is kind of the only place to learn more about the L method. So for finding the GCF, or greatest common factor, of 28 and 42, we'll want to work with 28 and 42. You can kind of put those numbers side by side, and this is kind of how we're going to use the L method. It looks like upside down division, and then you want to think what number can go into both 28 and 42. So you really are thinking like division, and you want to try to think of the biggest number. That's why it's called greatest common factor. That's why it's GCF. So you want to think of the biggest number that can go into it, but most importantly with the L method is that you just think of a number that can go into both of these numbers. So first of all, I'm going to just go ahead and start with a 2 because they're both even numbers, so I can always put a 2 out here. So I can go into 28 14 times and 42 21 times, but I know that I'm not done because these numbers are both composite numbers and they're both composed with a 7. So 7 can go into 14 twice and 21 3 times. And now at the very bottom I have two prime numbers. So I know that I can't go any further with this. Now here's the really neat thing about the L method is to find the GCF, all you do is look at the left hand side of your L method workspace, and you see that we have two numbers over here, and these are the two numbers that we use to break down our original 28 and 42. So we broke it down with a 2, and then we broke it down with a 7. So what we need to do is we need to take those two numbers and multiply them. So 2 times 7 is 14, and 14 is the GCF of both 28 and 42. So that's kind of how the L method works. Some of these other numbers that are here are important as well, but not for today's lesson in the GCF, so we won't quite get to that yet. So your answer is 14, and all the work that's shown above, that's what's expected for you to do for homework. Example number 2, find the GCF of 18 and 45. So we'll put 18 and 45. I know that I can't use a 2 here because 5 is an odd number. So I can check with my 3's. 1 plus 8 is 9. 4 plus 5 is 9. So I know that I can go into both of these numbers using a 3. So I can do 3 goes into 18 6 times, and 3 goes into 4 once, with I would have 15 left over. 3 goes into 15 5 times. So now I have 6 and 15. Well, I know that I can go into both of those with another 3. So I can go in twice with the 6 and 5 times here with the 15. So now 2 and 5 are both prime, so I know that I'm finished. And 3 times 3 is 9. So 9 is my greatest common factor. Now, some of you may have noticed right away that you could have gone into both of these numbers with a 9 immediately from the beginning. So if that's the case, you just need to go ahead and put a 9 out here. You can say, okay, we're going to go in 2 times and 5 times, and you can be done right away. So this is another reason why I really like the L method, is that it gives us more of an opportunity, so that way you can break it down a little bit smaller, and you can really look at all the fine pieces of the problem. Or if you know what the greatest common factor is right away, you can just use the L method to show your work. And I would expect for you to show me this work even if you know what the GCF is. So either way you do it, you're going to end up with the same answer as 9. So now we're going to do the GCF of 3 numbers. So again, we can use the L method, 21, 42, and 63, because we're going to need to find numbers that can go into all 3 numbers at the same exact time. Well, 21, 42, and 63. So you need to think about each number individually. I know that 3 times 7 is 21. I know that 6 times 7 is 42, and I know that 9 times 7 is 63. So the same number that I said there all those times was 7. 7 goes into 21 3 times, 7 goes into 42 6 times, and 7 goes into 63 9 times. Now I'm left with the numbers 3, 6, and 9, and I know that I can put a 3 in all of those numbers. So I'm going to break this down one more time. So this is once, twice, and 3 times. So 3 divided by 3 is 1, 6 divided by 3 is 2, 9 divided by 3 is 3, and now 1, 2, and 3, I can't do anything with those numbers. So my greatest common factor is this number right here, which is 7 times 3, and so my GCF is 21. Again, if you notice that right away, you could have just put a 21 over here and you would have been done with one step. So again, the L method is nice. You can use 1 step, 2 steps, or even more steps if you need them. So again, find the GCF of 3 numbers, 24, 48, and 60. So thinking about all these numbers, again, you want to try to think of the biggest number that can go into them all. Well, 24, 48, and 60, all of those can be divided by 6. 24 divided by 6 is 4, 48 divided by 6 is 8, and 60 divided by 6 is 10. And then I can divide all of those by a factor of 2, so I would have 2, 4, and 5. And I could break down 2 and 4 a little bit further, but I can't do anything with a 5, so in this case, I'm done. So 6 times 2 gets me my GCF. That should be a multiplication symbol. So the GCF for this problem is 12. So now we want to find the greatest common factor of these expressions. So 10JK and 15K. Well, the first thing I'd like to do is look at the variables, look at the letters. What letter is common to both? Well, a K is common to both. So let's take the K out of those problems. So I'm going to have 10J and 15. So notice I left the J there because I didn't factor the J out. Now we can look at the numbers. So 10 and 15, well, I can factor out a 5, and I get 2J and 3. So I can't do anything with the 2 and the 3, and I can't do anything with the J because both of them need to have it in order to factor it out. So I'm left with 5 times K, or in other words, I can write that as 5K. So my greatest common factor of both of these two expressions is the expression 5 times K, because both of them have a K, and I can factor out a 5 from both of their values. So in a candy problem, Alice is making candy baskets using chocolate hearts and lollipops. She is tying each piece of candy with either a red piece of string or a green piece of string. She has 64 inches of red string and 56 inches of green string. She wants to cut the pieces of string in equal length and use all the string she has. So what is the length of the longest piece of string that can be cut? And how many pieces of string can be cut from each color? Well, what we need to do is find the greatest common factor of our two numbers. We have 56 inches and we have 64 inches. So we need to break those two numbers down into the greatest common factor. So I'm thinking of these two numbers. I know that 8 goes into both. So 8 times 7 is 56 and 8 times 8 is 64. So what I'm left with here is 8 being the greatest common factor. So she wants to cut the pieces of string in equal length and use all the string she has. What is the length of the longest piece of string that can be cut? Well, she can cut it 8 inches long because That would be the greatest common factor. And we can make seven of the green bracelets, or seven of the green strings, and there would be eight, instead 64 inches of red string, so 8 red. So how many pieces of string can be cut from each color? 7 green pieces and 8 red pieces, because we can break it down like that. Again, all of them are 8 inches long, and I can make 7 of the green and 8 of the red. So that's our last example for today's lesson. You can check the online tutors, but remember they won't be using the L method. So you could watch the online tutors to see if you like maybe their methods better, and decide what you would like to do. You can also check the online step-by-step homework helper that I've also put on Moodle.